Envision a cosmic occurrence so immense that it casts shadows on Earth even during daylight. That's what might occur soon. Betelgeuse, a star in the Orion constellation, is exhibiting unusual behavior, indicating it may explode into a supernova, illuminating our sky like never before. Betelgeuse, located approximately 650 light-years away in Orion, is not just any star. It's a red supergiant, incredibly 100,000 times more radiant than our Sun. But why does it hold such significance? Betelgeuse is noteworthy not only for its brilliance but also for its importance in human culture. Named after the Arabic Yad al-Jawza, meaning the Hand of Orion, it has been observed for centuries, guiding travelers and enchanting stargazers with its reddish hue. Imagine a star so colossal it could encompass our solar system. At about 10 million years old, Betelgeuse is much younger than our Sun. Yet, its immense size causes it to deplete its fuel more quickly, leading to a shorter lifespan, now approaching the end of its existence. Betelgeuse is poised for a spectacular finale, a supernova explosion, releasing unfathomable energy and brilliance. The last time Earth witnessed such an event was in 1604, with a Kepler supernova visible even during daylight for weeks. Supernovae like Betelgeuse are rare, but their remnants provide valuable knowledge about the life cycles of massive stars. Betelgeuse's recent behavior has astronomers buzzing. Between October 2019 and early 2023, it experienced significant dimming, capturing global attention. Although it seemed to return to normal brightness by April 2023, subsequent months saw its luminosity surge by 50%, igniting discussions about its future. Could we be on the verge of witnessing one of the universe's most dramatic events? Its unpredictable behavior suggests we might be closer than we realize to experiencing its breathtaking explosion. Betelgeuse, one of the most recognized stars in our night sky, has suddenly thrown a celestial curveball. Stars are not just twinkling points of light, they are dynamic entities with life cycles, activities, and mysteries of their own. Periodic brightness variations can often be anticipated, much like the rhythms of Earth's seasons. Betelgeuse normally follows a fairly consistent 400-day luminosity cycle. However, with the great dimming, it seemed to defy its nature, challenging our comprehension of the celestial wonders above. A compelling theory has emerged. This theory, centered on stellar activity and mass ejection, proposes an enticing scenario. Imagine Betelgeuse as a gigantic celestial volcano suddenly erupting and expelling colossal amounts of its matter into space. Past observations from the Hubble Space Telescope revealed that Betelgeuse has previously ejected enormous amounts of surface material. One such ejection was 400 billion times the mass typically released during similar solar events, equivalent to several times the mass of our Moon. This created a dense dust cloud that temporarily obscured the star's brightness until it dissipated. Events like these hint at a star full of surprises. Many speculate Betelgeuse is nearing the twilight of its existence. A supernova is a cataclysmic explosion, an astounding burst of energy that can momentarily outshine an entire galaxy. This occurs when a star's core can no longer sustain nuclear fusion. In Betelgeuse's case, its nuclear fuel is depleting, causing its mass to collapse inward, setting the stage for a cataclysmic rebound. Stars like Betelgeuse begin life by burning hydrogen in their cores. This initial phase, the main sequence, lasts millions of years. Once hydrogen runs low, helium fusion takes over, forming carbon and oxygen. The star expands into a red giant, then shifts through progressively heavier element fusion. But when iron builds up at the core, fusion no longer produces energy. Gravity overwhelms, the core collapses, and a massive rebound triggers the supernova explosion. Recent research by Japan's Tohoku University suggests Betelgeuse may already be in its carbon-burning phase. Lead researcher Hideyuki Yamada believes its core might collapse a few decades after carbon reserves are gone. However, studies from Hungary's Konkoly Observatory argue Betelgeuse is still in the helium-burning stage. Regardless, scientists agree Betelgeuse is destined to become the Milky Way's next supernova. Yet timing remains uncertain, ranging from mere decades to 100,000 years. There's also a paradox worth noting. When we gaze at Betelgeuse, we're seeing it as it was 650 years ago. The light now reaching us began its journey when the Renaissance was just beginning. If Betelgeuse had already exploded, we would not know for centuries. The recent discovery of supernova SN 2023X in a nearby galaxy reminded astronomers of Betelgeuse's potential fate. That explosion, millions of light-years away, briefly outshone its host galaxy, offering a preview of what might come when Betelgeuse finally dies. According to Dr. Steny from Western University, when Betelgeuse detonates, it will briefly become one of the brightest objects in the sky, potentially outshining the moon. Night could turn into day for weeks. Afterward, the star's shell will expand into a nebula while its core collapses into a neutron star or black hole. Despite its brilliance, Betelgeuse's distance ensures Earth won't face catastrophic effects. The most we might experience are enhanced auroras from cosmic rays. Instead, the explosion will enrich the interstellar medium with heavy elements, fueling the birth of new stars and planets. For scientists, Betelgeuse's death would be a once-in-a-lifetime laboratory. It could allow detailed study of neutrinos, gravitational waves, and stellar collapse physics. For humanity, it would be a cultural milestone, rekindling wonder, inspiring art, and uniting people under a transformed night sky. In conclusion, Betelgeuse's eventual supernova is not just a scientific event. It is a reminder of impermanence, cosmic cycles, and our place in the universe. Its explosion will enrich the cosmos with the very ingredients of life: carbon, oxygen, and iron, continuing the eternal cycle of stellar death and rebirth. Moreover, Betelgeuse's expected explosion could deepen our understanding of gravitational waves. As massive stars collapse, they emit ripples in spacetime that travel across the universe. These waves, first detected in 2015, provide a new window into observing cosmic events. A nearby supernova such as Betelgeuse would offer an unparalleled opportunity to refine our models of stellar evolution and gravitational wave propagation. The event would also produce an extraordinary outpouring of neutrinos, elusive, nearly massless particles that rarely interact with matter. Detecting these particles in abundance would allow scientists to probe the inner workings of a collapsing star, unlocking details that electromagnetic observations alone cannot reveal. Beyond the scientific implications, the cultural and philosophical impact of Betelgeuse's supernova would be immense. For millennia, humans have looked to the stars for guidance, mythology, and meaning. A sudden, brilliant light dominating the heavens would not only reshape astronomy but also ignite new waves of inspiration in literature, art, and philosophy. It could mark a turning point in humanity's relationship with the cosmos, much like comets and eclipses did for earlier civilizations. Imagine generations of people looking skyward, united in awe by a singular celestial event, a cosmic beacon visible to everyone on Earth. Such a spectacle might even spark a new renaissance in scientific curiosity, encouraging global collaboration in astronomy and space exploration. Schools, observatories, and research centers worldwide would seize the opportunity to engage and inspire the next generation of scientists. And yet, amid all the speculation, one truth remains: Betelgeuse's fate is uncertain. Whether its supernova occurs tomorrow, centuries from now, or 100,000 years in the future, the star reminds us of the delicate balance between time and eternity. Every flicker in its brightness is a whisper from the cosmos, a hint that even the mightiest giants among the stars are not immortal. Betelgeuse's eventual death will not be the end of its story, but rather the beginning of countless others. The elements it releases will one day form new stars, new worlds, and perhaps even new life. In that sense, Betelgeuse's supernova will be both a conclusion and a genesis, a cosmic cycle continuing endlessly, shaping the future of the universe just as it has shaped our past.